Welcome to Ken Matrix Online Academy. Need assistance preparing for your KCSE or IGCSE exams? Connect with us on WhatsApp at 0790510099 or drop us an email at mwemican3@gmail.com. Today, it's an honor to introduce our online tutor, Engineer Ken Mwima, who will expertly lead us through this enlightening lecture. Welcome, sir. Your academic success is our priority. Join us on this journey of learning and achievement.
Thank you very much for that introduction. Today we are going to talk about a topic known as Introduction to Integration. A video has already been made on differentiation. So I recommend that you go through differentiation, the video that I uploaded a few days ago. So this is the outline of this tutorial. We are going to start with introduction, under which we are going to discuss about integration itself. We're going to see a definition of what integration is. Then under that, we are going to see the history of integration. Then after that, we are going to look at the real-life applications of integration. The second part of this particular tutorial, we are going to talk about application of integration in kinematics, in which case we are going to solve two particular problems that relate to kinematics, that is the study of motion without considering force. In the third section of this tutorial, we are going to see application of integration in computing area under the graph, in which case we are only going to solve one problem. On to the introduction. Like we defined differentiation in the previous tutorial, we are also going to do the same with integration. What is integration? Integration is computation of an integral. We may call it integrand, or rather adding slices to find the all. Integration is basically doing the opposite of differentiation. You realize that when you are doing finding a differential function, or rather a gradient function, you have an original equation. Now in integration, we kind of take in that gradient function to the original equation. We want to create an equation out of a gradient function. And in most of the cases, like we're going to see in the history of integration, it is kind of trying to find out area under the curve, most of which curves we might use some other approximate methods, but if we want to be very accurate, integration is employed. And this takes us to the history of integration. These two gentlemen, Isaac Newton, Gottfried Leibniz, who came up with the concept of calculus, that is integration and differentiation, they worked independently, in which case they were able to produce the meaning of integration and the concept of integration premised on the fact that it is the sum of the rectangles that are the infinite number of rectangles that have got infinitesimal width under the curve. So I think that is just a very rough idea of what integration is. Basically, it is just area under a curve. And a curve is generated from an equation. Now let us go to the real-life applications of integration. Where do we use integration in these particular areas that I've mentioned? Just to note, integration and differentiation, they are both looked at jointly most of the cases, and their applications are far-reached, such that we cannot exhaust all those applications in this particular tutorial. I'm just going to mention a few. We're going to start with astronomy, which is the study of space. When these astronomers, or rather the spacecraft engineers, want to plan on a mission to the space, they normally do some kind of integration to come up with the precise methods and procedures of launching rockets and other space mission activities. In structural engineering, in designing the bridges and truss structures, calculus is very important. Like, for instance, want to get the moment of inertia, section properties such as the moment of inertia. Calculus is integral. In electrical engineering, the engineers would like to design cables exact length that will transmit a certain voltage, and therefore that means integration and differentiation have to be used. Now let us now go to integration of polynomial. Integration is a very wide topic. In university, it can be studied in different units, and even when you finish your bachelor's degree, it still does not end there. So, for the starters, I think this video tutorial is important. Now, for my fellow learners who would like advanced calculus, just be patient. I'm going to drop more videos on whatever that you might be eager to know. Now, for the beginners, we are going to focus on integration of polynomial. There are many functions that can be integrated. Now, like I have said, integration is kind of bringing back the gradient function to its original equation. Now, if dy dx is equal to a polynomial function such as dy dx is equal to x raised to power n, an integral or an integrand I is equal to that. Now this one, let us note this. This is a sign of integral. It is called an integral sign, or rather an integrand. Want to get an integrand to bring it back to the original equation? You use this integrand sign. Integral of x raised to power n with respect to x, and that's why I say dx with respect to x. Then then the integral of x raised to power n with respect to x is equal to x x raised to power n, x raised to power n plus 1 over n plus 1. So what you're going to do here is to add n, x raised to power n plus 1 over n plus 1. So you have to add 1 to the power and then you divide by n plus 1. But you'll have to add a constant there, arbitrary constant. We are going to see in the example that I'm going to show you. There is an arbitrary constant that you need to add. So, e.g., if 3x squared minus 1 is a gradient function, you can see 3x minus 1, the derivative, the gradient for the integral is given by this. Now, what has just happened is that this is 3x squared plus, so you have to add 2 plus 1 over 2 plus 1. Let me use a pen to showcase this. I just want to assume that you are a beginner. So we have to add 1 there, then we divide by 2 plus 1. And that is what you get, 3x squared plus 1 over 2 plus 1 minus, now this 1 is the same as 1 times x raised to power 0. And you need to note that x raised to power 0 is equal to 1. You need to note that. After noting that, then we can comfortably say, in this case here, we can comfortably say the integral of x is equal to x power 0 plus 1 integral of 1 is equal to x power 0 plus 1 as shown there, divided by 0 plus 1 plus c. Now what is c? C is known as arbitrary constant. Some people may call it constant of integration. It's called arbitrary constant. And now, what is the final answer? What is the destination to this particular problem? X cubed minus x plus c. So what is this? This is the integral function. It is the integral function. So this is what we have integrated from here. We have been able to integrate 3x squared, and then so that we are able to get this as the original function. Now, just note, because later on we are going to look at definite integrals, if an integral is not defined within some given limits, such as we have the upper limit and the lower limit, then it is very prudent that you add an arbitrary constant. Okay, let us now go to the next slide. The next slide, we have a question from kinematics. Kinematics, like we had mentioned earlier in our previous lecture on differentiation, kinematics is a very important area in mechanics that uses differentiation and integration a lot. Now, let us go straight to the question. A particle was moving along a straight line. The acceleration of the particle after t seconds was given by, let me use a a highlighter here, was given by 9 minus 3t meters per square second. The initial velocity of the particle was 7 meters per second. Find the velocity of the particle at any given time. The velocity of the particle at any given time. Now, this question is asking us to come up with an equation of velocity. We have already been given acceleration. So what we need to is to use acceleration to get velocity. Now SVA, let me use a different color. From acceleration to this direction, I'm going to integrate. From that to that direction, we're supposed to differentiate. So for me to get velocity, that means I'll have to integrate the acceleration function. Okay, so velocity is equal to the integral of acceleration with respect to t. Now note that here we are using t as our independent variable, so the integration will be with respect to t, not with respect to x. Now, for us to make sure that we are doing it with respect to t, then for us to make sure that we are doing the integration with respect to t, we have to bring that here. We have to do the substitution that way. We have to bring the all of this equation, the all of this function, and substitute here. And after doing the substitution, now the integration process can proceed. Now you see, this is what has happened. This is the substitution. We have substituted the acceleration function. Now next is to do the integration process. The integration process is as follows. Now you can see 90 t raised to power 0 plus 1. Why are we saying t raised to power 0? Because 9 was just there alone, and we need to know that anything that is raised to power 0 is equal to 1. That's why we are including t power 0 plus 1 over 0 plus 1 minus 3t, because t alone is just the same as t raised to power 1 plus 1 over 1 plus 1 plus an arbitrary constant. Now, let us see what it brings us to. It brings this: v is equal to 90 minus 3t squared over 2 plus arbitrary constant. One thing to note here, we have to know what this is. We have to get the value of this arbitrary constant for the velocity to be for the velocity function to be complete. And now we're going to arrive at that. Now that we have already been given the initial conditions, the initial conditions are the value of t is 0 and the value of v velocity, initial velocity, is 7 meters per second. Then doing the substitution of those values, whereby in the t we substitute 0 in the t, and we substitute 7 in the v, and that is the substitution. That is a substitution. So where we have t, we substitute with 0. Where we have v, we substitute with 7. And then after doing the substitution, the value of c is 7. And now we can comfortably replace the value of c with the 7. And the equation now is complete. The expression is complete, and that is the expression for velocity. Velocity is equal to 90 minus 3t squared over 2 plus 7. Let us go to the next part of this problem. Find the maximum velocity of the particle. Let me use a highlighter here. Highlighter will be important. And if we can change the color, let me use color red, which is normally very loud. The maximum velocity. Find the maximum velocity. Maximum velocity is when acceleration is equal to 0. When acceleration is equal to 0, then we say the velocity is maximum. But we cannot just get velocity straight away. We have to get the time when velocity was maximum. And then we substitute the time in the velocity function. So we are going to start from acceleration. So acceleration, that is the equation for acceleration. Acceleration is equal to 9 minus 3t. But we have said that acceleration is equal to 0 when velocity is maximum. So we have to equate that with the 0, like we have seen. And after equating it to 0, we ought to find the value of t as follows. So t is equal to 3 seconds. So substituting for t in the velocity function, when you substitute for t in the velocity function, you look at that, you substitute the value of t in the velocity function, we have that is the velocity function. So what we're going to do, we are going to write 3 here. Substitute with the 3. Where we have ft, substitute with the 3 for us to get the maximum, like as shown. So 3. And after doing the computation, we arrive at 20.5 meters per second. So that is the maximum velocity attained by the particle in motion. Let us go to the next part of this problem. Calculate the distance covered by the particle by the time it attained maximum velocity. Now, what is distance? What is distance? Let me use a highlighter here. Highlighter. What is distance? And what are we talking about when velocity was maximum? Remember that the motion started when when at the initial stage, when time was 0, and the maximum velocity that was attained, it was attained when time was 3 seconds. So now, like I have mentioned earlier, we are going to see what this means. Now, we are going to do an integration based on definite integral. Call that t1, call that maybe t0, so that this becomes the upper limit and this becomes the lower limit. In our case, our upper limit will be 3 seconds, our lower limit will be 0 seconds. And because we really need displacement, just note that displacement is just distance, but displacement is distance in a defined direction. So we'll have to integrate this velocity with respect to t. So this is going to be a definite integral that has got limits, upper limit and lower limit. So let us see what is going to happen. So S is equal to, like you have seen, integral of V. So for us to get displacement, we'll have to integrate a velocity function. So S is equal to integral of velocity from T2 to T1, where T2 is the lower limit, T1 is the upper limit. And since V is equal to 90 minus 3t squared over 2 plus 7, like this is what we have. These are just the results. These are just the one of the results of the previous calculations. So we're going to use that. We're going to just substitute this here, like we're going as shown in the next step, in the subsequent step. See that substitution? Now the whole of that is velocity. So we are going to integrate again, but remember here the integration will be between these limits, limit of integration. So now when we have limits of integration, we normally assume or normally ignore the arbitrary constant, or rather the constant of integration. So we're going to ignore it, so that because even if we put it there, it is going to cancel. That is only applicable for definite integrals. Now let us see the integration. Let us see the integration. So this is how the integration takes place. You see t 90 plus 1 over 1 plus 1. So we are going to look at the variable. We look at the power in which it is raised. You add 1 to the power divided by 1 plus 1 minus 3 over 2. You can see this is 2 squared. Just add 1 over. Now the trick here is whatever you get here, just drop it here down. Okay, drop it there. So that sum, drop that sum here. 2 plus 1, then 2 plus 1 is 3. 3 times 2 is 6. 2 plus 1 is 2. So that's 9 over 2. 3 over 2 times 1 over 6. We're going to get, we're going to see the results. So let us see the final results. That is, S is equal to 9t squared over 2 minus 3t cubed over 6 plus 7. Now that this is a definite integral, we are going to do integration between the limits. So we are going to substitute 3 in this, and then we say and also substitute the 0 in this particular integrand. So what you're going to see is that the displacement is equal to upper limit or upper limit substitution, let me call it subs, minus lower limit substitutions, lower limit subs. So we are going to substitute 3 here, substitute 3 there where we have t, and then get the result. Subtract where we have substitute 0, get the result. So let us see what is going to happen. So that is what is going to happen. Let me use a highlighter in this case. You look at that. That is substitution for 3 minus that substitution for 0. So in the first case, we have substituted 3 everywhere. We have just duplicated. You're just duplicating the all of this equation here. In the first bracket, you also do the same for the second bracket. But now the substitution is different. In the first bracket, you input the upper limit. In the second bracket, you input the lower limit. Then the final answer becomes 174 meters. So let us go to the next problem. Next problem is still under kinematics. Still under kinematics. So let me read the question. The acceleration of a body moving along a straight line is 4 minus t meters per square second, and its velocity v meters per square second after t seconds. If the initial velocity of the body is 3 meters per second, express the velocity in terms of t. So, like we have stated earlier, for us to get the velocity function, okay, we have to integrate the acceleration function. So that is what is going to happen. And this is the acceleration function. The acceleration function. So we are going to integrate that. So integration is going to be very simple, just like the previous one. So 0 for t power 0 same as 1. So 0 plus 1 over 0 plus 1 minus 4t raised to power 1 plus 1 over 1 plus 1 plus arbitrary constant. So 40, yeah, so that is going to be the result. Now, because we have given the initial conditions, we are just going to substitute these initial conditions there. And after doing the substitution, we arrive at c is equal to 3. And then the equation can be rewritten. That is c. Okay, can be fashioned in such a manner that we have the numericals, the numbers, and the t. So v is equal to 4t minus t squared over 2 plus 3. So find the velocity of the body after 2 seconds. Velocity of the body after 2 seconds. The velocity of the body after 2 seconds. Now that we already have the velocity function, we are just going to substitute 2 in the velocity function that we have already found, and then we get the answer, 9 meters per second. The next question is asking, calculate the time taken to attain maximum velocity. Like I said, maximum velocity is when acceleration is equal to 0. So since acceleration is 4 minus t, we're just going to equate that to t and get t. T is equal to 4 seconds. And then find the distance covered by the body to attain the maximum velocity. Like we have done with the first one, it is this kind of a problem is a definite integral. Integration from the lower limit to the upper limit. So that is since we already have velocity function, that is the velocity function, what you do is we integrate. Let us see the integration. Now this time around they may use a green color. So this is the integration. Just note that the time is 4 seconds. That the time to attain maximum velocity is 4 seconds, and the initial time is 0 seconds. So the integration is going to be between 0 to 4. And now I think from now you know how the integration takes place. So that is the integration. You can have a look. So t power 1 over 1 over 1 plus 1. You have to make sure that you add this power plus 1. Then you divide by the power plus 1. Like 2. Now look at here. Look at that. It just looks like this. So that is what we are going to do throughout. Okay. Yeah, like that. Then because it's a definite integral, you'll have to do the substitutions like I had highlighted earlier. Maybe if I can highlight it once again. Okay, so we have that, the first bracket, then we have the second bracket. So you get the difference between the upper limit substitutions minus the lower limit substitutions, and the answer is 3.33 meters. On to the last question. Now this question is on the curve, the area under the graph, or area under the curve. So let us see what the question demands before we even attempt it. The gradient function of a curve is given by the expression 2x plus 1 if the curve passes through the points -4 and 6. Find the equation of the curve. So for us to find the equation of the curve, we have to highlight a number of things here. Let us first of all highlight what we provided with, the gradient function. So that means this is a gradient function, 2x plus 1. It passes through these coordinates, and we have to make sure we have identified these coordinates. This is x coordinate, this is y coordinate. So very important that we identify the coordinates. Now this is a gradient function, this one here. So dy dx is equal to 2x plus 1, because it has been stated that 2x plus 1 is a gradient function. So that means we want to get it back to the original equation. Now we're going to arrive to that. We have to integrate 2x plus 1. So that is the integration. Y is equal to the integral of 2x plus 1 with respect to x. That should be x, not t. That should be x with respect to x. And therefore, after doing all that we integrate. So let me use a highlighter here. So this is 2x plus 1 over 1 plus 1. X raised to the power 0 plus 1 over 0 plus 1 plus arbitrary constant. Very important that you add the arbitrary constant. That is if you are not provided with the limits of integration. Then it boils down to 2x, y is equal to 2x squared over 2 plus x plus c. So this is the final x squared plus c plus x plus c. Okay. Now, can you recall where we got this from? Where these ones come from? Can you recall where these ones come from? These are the coordinates. Okay. So the y coordinate is 6. And the x coordinate is, these are the points where the line, they were -4, 6. The point where the curve passes, -4, 6. Okay, so we are going to do the substitutions based on this in the equation. So where we have y, we substitute with 6. Where we have x, we substitute the minus 4 as shown that way. So 6 is equal to 6 is equal to minus 4 squared plus minus 4. So these are excess of x substitutions plus c. The main idea here is to get c. So after doing that, c is equal to negative 6. And since c is equal to negative 6, we are going to substitute. We are going to substitute. So look at the substitutions. This is the value of c. The value of c is negative 6. So we have substituted. So the equation of that curve is given by y is equal to x squared plus x minus 6. On to the next stage of this question. The value of x at which the curve cuts the x-axis. Find the values of x at which the curve cuts the x-axis. Now look at this equation here. We want to get the value of x in which the curve cuts the x-axis. Look at that equation. Look at that equation. It tells you that this equation is a quadratic function. Now, where the graph cuts the x-axis, the value of y must be equal to 0. Must be equal to 0, so that we can solve that quadratic equation. And now y is equal to that. Y is equal to that. That one is equal to 0. And after equating it to 0, we can now get the values of x. X is minus 3 or 2, maybe using factorization method. Okay, let us go to the next part of the problem. Determine the area enclosed by the curve and the x-axis. So this is the graph. We have already gotten the limits of integration as minus 3 and 2. Now, the points where the curve is being touched, these are the limits of integration. We don't need to ask ourselves where do you get the limits of integration, and it has not been provided in the question. Already these are the limits of integration. So what you're going to do, we use them. Now this is just a sketch that I made prior to this session, and it's always important that you use a sketch to visualize. Now, for the purpose of illustration, I think this one will be important to help you understand. Now, those are the limits of integration. So what you're going to do, we are going to do an integration. Remember that at point you are asked to find the area under a graph, you have to integrate. So we integrate what? We are going to integrate this equation. Sorry, this function, the function. Okay, so let us see the integration. The function is y is equal to x squared plus x minus 6. So let us integrate it. But remember, this is the upper limit, this is the lower limit. The point where the curve cuts the x-axis, 2 and negative 3. We integrate this equation, okay, with respect to, should be with respect to x, not t, with respect to x, because we are using x's, so with respect to x. So let us look at the integration. So that is it, x squared plus 1 over 2 plus 1 plus x raised to power 1 plus 1 over 1 plus 1 minus 6x raised to power 0 plus 1 over 0 plus 1 within the limits of integration. Once again, and so this it has been simplified up to that. Once again, because we are talking about a definite integral, we have to indicate, we have to do the substitution separately and subtract. These are the upper limit substitutions. These are the lower limit substitutions. So look at minus 3. Okay, minus 3. Where we have t, substitute the minus 3 in that side. In the right hand side, where we have t, substitute the 2. So that is what has happened. And then the final answer is 20.83 square units. So that is the end of our tutorial. If the tutorial has benefited you, consider subscribing to this channel in order to get more content. Thank you. Let's meet in the next video.